So let's talk about the second material, that is for the semiconductors. Our question is effect of the temperature on resistivity and resistance. We have discussed for the first material, that was for the metals, and in case of metals we have seen the effect of temperature was changing linearly with respect to the resistance and resistivity. That means resistance and resistivity for metals, they increase with the increase in the temperature and they decrease with the decrease in the temperature. Okay. Let's talk about for the second material, that is for the semiconductors. Here we will talk about for the semiconductors what will be the effect of R and rho, that is the resistance and resistivity, for a circuit which is having a material exhibited in it, that is a semiconductor. Okay beta, we have so many semiconductors. As you have seen in the periodic table, we have germanium, we have silicon, carbon is also recorded as a semiconductor, we have gallium, arsenic, etc. They all are semiconductors. Okay beta, but as far as their conductivity is concerned, the semiconductors, agar मैं I will talk about the pure semiconductors without any impurity in it, pure semiconductor beta. So pure semiconductor में at zero Kelvin they behave as insulators. So अगर मैं 0 Kelvin temperature की बात करूँगा, pure semiconductor behave as insulators. Goburmion imshkaran behave as insulators. What are insulators? Insulators are the substances which do not possess any sort of conductivity. That means at 0 Kelvin they show maximum resistance. They exhibit maximum resistance to the flow of current. Are you getting me beta? So normally अगर मैं pure semiconductor की बात करूँगा, at 0 Kelvin these pure semiconductors without any sort of impurity, because अगर मैं इनको impurity add करूँगा, their conductivity is going to rise. So that's why I'm talking about the pure semiconductor. Here pure semiconductors at 0 degrees Celsius behave as insulators. They behave as insulators. That means they exhibit or they show maximum resistance to the flow of current. Okay, so our question is, what will be the effect of the temperature if I'm going to increase the temperature for a material which is having a semiconductor? What's going to be the effect on resistance and resistivity? And we are familiar in the first lecture as well as in the second lecture, while talking about the metals, we are keeping the two parameters constant. That is, yes, that is the length and area of the cross section of the current. Oh, sorry, a conductor. We are keeping those parameters as constant terms, constant parameters. Okay, so let's go for the this formula for the resistance. We have R is inversely proportional to N and tau, because only the two parameters are the functions of the temperature and they are going to vary. Rest of the terms involved in the resistance or resistivity, they are constant. Here rho is also inversely proportional to n and tau, and you are quite familiar, quite you're well known about the parameters that are involved in it. N is the number density of the free electrons, number of free electrons available in per meter cube. And while talking about the metals, I'm talking about the metals at normally room temperature metals में 10 raised to power 29 free electrons available होते हैं. Okay, but the story is for semiconductors now. Semiconductors में बेटा आपको यहाँ पे free electrons नहीं मिलते हैं. Okay, यहाँ पे there are least number of free electrons So there are least number of free electrons in semiconductors. In semiconductors, are you getting me बेटा? So जो मैं metals की बात कर रहा था वो यहाँ पे नहीं अप्लाई होगा. यहाँ पे least number of free electrons होते हैं. अगर मैं इन सेमीकंडक्टर्स की बात करूंगा, हियर वी हैव फॉर एग्जांपल जर्मेनियम है, सिलिकॉन है, कार्बन है, दे ऑल आर बाउंडेड विद द कोवेलेंट बॉन्ड्स. as you have seen in the you might have read in the carbon and its compounds, ये जो carbon होता है it has a covalency, it has a it's a tetravalent non-metal or tetravalent element, huh? It shows the valency of it has a tetravalency, it is bounded with the carbon, it's bounded with the covalent bond. Okay, same is the case with the semiconductors. Here, germanium, silicon, carbon, gallium, arsenic. They are all bounded with the covalent bonds with having valency or having valency as 4. As having valency 4. Let's talk about the germanium. Here, suppose we have the germanium here. I'm talking about the atomic structure of the germanium. Germanium की valency जो है, it has 4 valency. Okay, it's bounded with the other germanium atom. Other germanium atom, let us suppose it has also a 4 valency. Here also 4 valency because we have to complete its octet. Okay, here also 4 valency. यहाँ पे भी मैं germanium लूँगा. Okay, and this germanium and this germanium is bounded with the bond that is called as covalent bond, leaving behind least number of I can say the free electrons. Okay, यहाँ पे availability of free electrons नहीं है. अब हमने क्या करना है, हमने स्टडी करना है. वी हैव टू स्टडी आउट द वी हैव टू स्टडी आउट द केस ऑफ आर. What will be the effect of R, that is the resistance and resistivity, when we are using a material that is a semiconductor. Okay, and while talking about the structure of the semiconductor, so suppose we have the germanium, same will be applicable for other atoms as well. Okay, so here germanium is bounded to other germanium atom or other atom with the covalent bond having valency 4, as it completed its octet. Okay beta, as I supply energy. Now I have to increase the temperature. On increasing in the temperature means I am supplying the energy. When I supply this energy, when I supply energy to this germanium, okay, as already germanium is bounded with the covalent bonds. The covalent bond जो होता है, number of free electrons जो होते हैं वहाँ पे, the bond starts to break up. The covalent bond starts to break up. So यहाँ पे क्या होता है, जब हम सप्लाई करेंगे एनर्जी, आपको पता है जो covalent bond होता है, covalent bond is not stronger than, it's not so much stronger as compared to the ionic bond. Ionic bond is quite stronger as compared to the covalent bond. Okay, so अगर मैं यहाँ पे थोड़ी सी भी एनर्जी सप्लाई करूँगा इस एटम को, so इससे क्या होगा, इस मटेरियल को, सेमीकंडक्टर को, यहाँ पे क्या होता है, the covalent bond will start to break. एंड वहाँ पे क्या होता है, वहाँ पे ये जब ब्रेक होगा तो यहाँ पे एक इलेक्ट्रॉन बाहर निकलेगा, that will be regarded as the free electron. That will be regarded as the free electron. यहाँ पे प्रोड्यूस होता है free electron. When it is going to produce free electron, yes, when it's supplied with the energy or when temperature is increased. But बेटा यहाँ पे जब ये free electron यहाँ पे release करेगा, it will leave a space here, and this is called as, it will leave a hole here. It will leave a hole here. So यहाँ पे क्या होता है, यहाँ पे 2 चार्ज कैरियर्स बन जाते हैं. चार्ज कैरियर्स मतलब गोबर कंडक्टिविटी हेल्प करने में. यहाँ पे एज यू आर फैमिलियर विद द मेटल्स, यहाँ पे जो कंडक्शन इन मेटल्स होता है, दैट इज ड्यू टू द प्रेजेंस ऑफ द फ्री इलेक्ट्रॉन्स. नाउ यहाँ पे केस अलग सा है, यहाँ पे ऐड होता है. यहाँ पे क्या होता है, द कंडक्टिविटी इन केस ऑफ सेमी कंडक्टर्स, इफ आई increase the temperature, there are 2 charge carriers present. Here the free electron, here is one is the free electron, and second is the hole. Number second. So because of the free electrons and the holes, the semiconductor behave as the conducting material. But ये possible कब होगा, जब हम इसको supply करेंगे यहाँ से energy. Are you getting me? So in case of metals, only one charge carrier particle is present, that is the free electron. But in case of semiconductor, we have got 2 charge carriers. One is the free electron and number of second is the holes. अगर आपको कोई पूछेगा, बताइए आप semiconductor में conductivity कैसे होती है, so आप इनको यही बताओगे कि सर यहाँ पे जो semiconductors की अगर हम बात करेंगे, वहाँ पे 2 charge carriers जो होते हैं वो free electrons होते हैं, as well as the holes. as well as the holes. So अगर मैं आपको यहाँ पे बोलूँ कि एन पे क्या इफेक्ट पड़ेगा, आप एन पे क्या इफेक्ट पड़ेगा, एन डिक्रीज इंक्रीज करेगा और एन डिक्रीज करेगा. सो आई हैव टू स्टडी आउट फर्स्ट केस इज एन. एन इज मतलब गो, एन मतलब गो नंबर डेंसिटी ऑफ द फ्री इलेक्ट्रॉन्स. अब इट्स क्लियर कि ऑन इंक्रीज इन द टेम्परेचर द covalent bond breaks and as there is the production of more and more free electrons. As a result of it, this will go on increasing, as you have seen in the first lecture, that is for the metals. As we go on increasing in the temp as we go on increasing the temperature, the number density of the free electrons increase. Are you getting me? So here the first parameter is for n. Here we are increasing the temperature and subsequently n also goes on increasing. Are you getting me? So this is number first. While talking about the second parameter, because we have to deal with the two parameters, one is the n. We have seen that on increase in the temperature, that number of density of the free electrons in case of the semiconductors, those increase. Now talking about the tau, that is the relaxation time. Same here, we are increasing the temperature and relaxation time, that is a tau is going to decrease, as we have well mentioned, we have explained it in the first lecture. What was the effect of the n, that is the what was the effect of number density of the free electrons and the relaxation time when we increase the temperature. We have explained it in this first lecture as well for the metals when we discussed that. Okay, so on increase in the temperature, here we are increasing, we have seen that the number density of free electrons get increased. Number second, on increasing in the temperature, for any for a material having semiconductor in a circuit, the relaxation time gets decreased. Okay beta. So अगर मैं यहाँ पे रेजिस्टेंस और रेजिस्टिविटी की बात करूँगा, रेजिस्टेंस इज इनवर्सली प्रोपोर्शनल टू n and tau. Resistivity is also inversely proportional to n and tau. Okay, here also n increases as we are increasing the temperature, we are supplying the energy. N increases, R decreases. Are you getting me? Here also temperature increase करने से tau decrease करेगा and R increase करेगा. Same is the story for the resistivity as well. Tau, on increase in the temperature, we have the parameter n that is going to increase, and subsequently this will go on decreasing. What this is the resistivity. Same, on increase in the temperature, we have the relaxation time that is going to decrease, and this will go on increasing because they have the inverse relationship, this resistivity. Are you getting me? So यहाँ पे भी मैं देख रहा हूँ कि एक पैरामीटर इंक्रीज हो रहा है और रेजिस्टेंस जो है जो डिक्रीज कर रही है, एंड सेकंड केस में इंक्रीज कर रही है. बट वी हैव टू कम टू द पॉइंट कि रेजिस्टेंस पे फाइनल इफेक्ट क्या पड़ेगा. सेम. नाउ here the two parameters जो है, out of the two parameters we have to figure out the dominant one. Out of the two parameters. Which are the two parameters? Number one is n, and number second we have the tau, that is the relaxation time. Out of the two parameters we have to figure out who is playing the dominant role among the two. बेटा देखो, अगर यहाँ पे फ्री इलेक्ट्रॉन्स नहीं होते, देखो अगर यहाँ तो at room temperature, without supplying the temperature, without supplying the energy, without supplying the temperature, without increasing the temperature, we have least number of the free electrons. अब देखो, अब मैं यहाँ से इंक्रीज कर रहा हूँ टेम्परेचर, दैट मीन्स आई एम सप्लाइंग द एनर्जी. एज ए रिजल्ट ऑफ दैट एप्लीकेशन ऑफ एनर्जी, द कोवलेंट बॉन्ड स्टार्ट्स टू ब्रेक. उसके बाद हमारा ये फ्री इलेक्ट्रॉन है, इसकी जो प्रोडक्शन हुई, इंक्रीज इन द फ्री इलेक्ट्रॉन्स हैपन. ओके, अब देखो, जब हमारा ये जो इंक्रीज इन द फ्री इलेक्ट्रॉन्स होते हैं, इंक्रीज इन द फ्री इलेक्ट्रॉन्स रिजल्ट इन द डिक्रीज इन द रिलैक्सेशन टाइम. बिकॉज जितना हम टेम्परेचर इंक्रीज करेंगे, उतनी ही ज़्यादा फ्री इलेक्ट्रॉन्स प्रोड्यूस होंगे यहाँ पे. अब देखो, अब इसमें से आप बताइए मुझे, इसमें से पॉसिबल डोमिनेंट रोल क्या हो सकता है? दैट विल बी एन. वाई? बिकॉज एन की वजह से टॉ आ रहा है हमारा. अगर एन ना होता तो टॉ भी नहीं आता. आर यू गेटिंग मी? अगर यहाँ पे अवेलेबिलिटी ऑफ फ्री इलेक्ट्रॉन्स तो नहीं थे, अब हमने यहाँ पे वी हैव सप्लाइड द एनर्जी टू इट, we have supplied the energy to the semiconductor. As a result of it, n got increased. When n got increases, there happens to be the production of more and more free electrons. As a result of it, उसके बाद दूसरा पैरामीटर कंसिडरेशन में आया, दैट वाज द रिलैक्सेशन टाइम. रिलैक्सेशन टाइम क्या होता है? इट्स द एवरेज रिलैक्सेशन टाइम दैट इज टेकन, द टाइम टेकन बाय द एवरेज टाइम टेकन बाय द फ्री इलेक्ट्रॉन्स. अगर यहाँ पे फ्री इलेक्ट्रॉन्स नहीं होते तो एवरेज रिलैक्सेशन टाइम का कॉन्सेप्ट भी नहीं आता. बट यहाँ पे जो पहले हमारा जो एन था, एन को प्रोड्यूस करना था. एन को प्रोड्यूस कैसे किया हमने? एन को प्रोड्यूस हमने यहाँ पे एनर्जी जब दी है तो एन नंबर ऑफ फ्री इलेक्ट्रॉन्स प्रोड्यूस ज़्यादा से ज़्यादा इंक्रीज हो गए. एज ए रिजल्ट ऑफ इट द सेकेंड पैरामीटर केम इनटू एग्जिस्टेंस. मेटल्स में केस अलग सा था. मेटल्स में ऑलरेडी प्रेजेंट थे ये एन वाला फैक्टर जो ऑलरेडी प्रेजेंट था, यहाँ पे नहीं था. यहाँ पे हमने प्रोड्यूस किया इसको, हमने इंक्रीज कराया इसको. वाई? हाउ वी हैव इंक्रीज दैट? बाय सप्लाइंग द टेम्परेचर. So out of the two factors, this n plays the dominant role. This n plays the significant role. So n is the deciding factor here. N is the deciding factor here. We have to see the case for n. What happens to the n? Ultimately the resistance is going to vary. So n आपको पता है कि on increase in the temperature, on increasing the temperature, n increases. When n increases, आप मुझे बताइए सर, out of the two, ये तो play कर रहा है dominant role. It is the barbarism now. This is the side substituent player now. Okay, अब n जो है, n हमारा increase कर रहा है. What is going to be the effect on resistance or resistivity? Here also same happens with r is going to decrease. R is going to decrease. सेम, अगर टेम्परेचर इंक्रीज करूंगा n इंक्रीज करेगा, रो भी डिक्रीज करेगा. सो व्हाट हैपेंस टू द अल्टीमेट टेम्परेचर, व्हाट हैपेंस टू द इफेक्ट ऑफ द टेम्परेचर ऑन रेजिस्टेंस, ऑन रेजिस्टिविटी? ऑन इंक्रीज इन द टेम्परेचर, द रेजिस्टेंस एंड द रेजिस्टिविटी फॉर द सेमीकंडक्टर्स, they decreases. So we have come to the conclusion that on increase in the temperature, the resistance and the resistivity, they vary inversely. That means when we increase the temperature for the semiconductor, the less resistance will be offered by the semiconductor to the flow of current. Are you getting me? Subsequently, it is the same case that is happening for the resistivity as well, and vice versa. अगर हम T को decrease करेंगे, N decrease करेगा. When N decrease करेगा, so R will obviously increase, and same will be happening to the resistivity. Are you getting me? So we have come to the conclusion. In nutshell, I can tell you that when we increase the temperature for a material which has a semiconductor in a circuit, which has a semiconductor, the net effect for the resistance and resistivity, that will vary inversely. That means we increase the temperature, less resistance will be offered by the by the semiconductor. Less resistance will be offered by the semiconductor, and same way the effect of the resistivity will also decrease. And this was all about for the second material, that is the semiconductor.